Hey guys, so welcome to video lecture. All right, so intro to quadratics part 2. So if you were here yesterday, this is the same lesson, okay? And what you're going to do is, um, sorry, no new journal header, uh, just where you left off from yesterday, okay? And so today we're going to be actually making a very nice graph of quadratics. Yesterday we learned how to sketch just a rudimentary graph of quadratics. Today we're just going to be actually graphing on graph paper. And so the steps to graphing a quadratic equation, first we're going to find the axis of symmetry. We're going to find the vertex. We're going to put the vertex in our middle row in our table, okay? And then fill in the tables of values, and we'll use our calculators for this, all right? And number 4, we're going to plot the points and make a nice looking parabola. So, ready? Let's go. Okay, y equals x squared. Something you need to know, this is the parent function. And what is the parent function? Well, bring that back. The parent function. Well, the parent function is the most simplistic quadratic equation that you'll see. And so if you put it in your calculator, turn on your calculator. All right, pause whenever you need to on the video. Go to y equals, and I'm just going to put in x squared. Okay. All right. Now, before we go to the table, I need to find my axis of symmetry. And of course, the axis of symmetry is x equals negative b over 2a. Well, I got no b, right? So my b is going to be 0 over 2 times 1, and that's just 0. So x equals 0, okay? So now I'm going to go to the table in my calculator, and you hit second graph on your calculator, and I'm going to go find x equals 0, and you can see what is my y value next to x equals 0. Well, it's 0, 0, and that's my vertex. Okay. All right, and we'll do the domain and range here later, and I'm going to put the vertex in the middle of the table, and then I'm going to find the 2 points before and after. And so that's going to be -2, -1, then 1, 2. Okay? And what you're going to see here is that for 1, our y is 1. And the same thing for -1. Okay? So remember, vertex is the point that splits the parabola into 2 symmetrical sections. So everything to the left and right of the parabola is now going to be symmetrical. And so 2 is 4. All right? And same thing for -4. And so now I can plot this. I got 0, 0 here. And then I got 1, 1. Okay? And then I have 2, 4. And -2, 4. And so right here I can kind of make myself a nice little graph like that. Okay, so let's talk about domains. Unless there's any constraints, the domain for a quadratic is always from -infinity to +infinity. Now here, the range is everything we got. Now the range can be different though. If you can see, my graph is going to open up. So it has a minimum. And so y is greater or equal to 0. All right? So it will hit every y value above 0. Okay, let's do another. Now, x squared plus 2x minus 1. All right, I need to find my axis of symmetry first. X equals -b over 2a. This time we have a b, right? It's 2, so -2 over 2 times 1 is -1. Okay, so x equals -1, and I'm going to put that in the middle of my table. Going to do x squared plus 2x in my calculator in the y equals. And then I'm going to go to second graph to the table, and I'm going to find where x is -1. Okay, when x is -1, y is -2. And then I'm going to do the points around it. So it is going to be -2, -3, and it's going to be 0, 1. Okay? And when x is when x is 0, y is -1. And that's the same true for -2. And when x is 1 or -3, y is 7. Or sorry, not 7, it's 2. That's my bad. Okay. Alright, so my vertex, I need to fill this out as -1, -2. Alright, and I'm going to go find that vertex, -1, -2, which is right here. Okay. Alright, now I find the other points. When it's -2, it's -1. Alright, and then when it's 1, it's 2. And when it's -3, it's 2. Okay, and you can see there's the symmetry, right? And graph that line, or graph that parabola. Alright. And again, my domain is what I said. It's going to be -infinity to +infinity. All right, so it's going to hit every x value. It doesn't look like it is, but given enough time, it will hit all the x's. Okay. And the range, though, we have another minimum, and this time my y is going to be greater than -2. And if you're asking, well, Mr. Simpson, how do I know? Well, you just kind of have to realize my parabola opens up, so it's a minimum, all right? And so everything is going to be, every y value is going to be greater or equal to -2, okay? So that's how I know. All right. And I got one dropping stuff in the background here. Okay. Here we go. And moving on to the next one. So number 3. All right. When you look at this, -x² minus 8x minus 17, is this going to open up or down? Well, hopefully you said it's going to open down, which is true. Okay. And let's figure out what my axis of symmetry is. It's -b over 2a. My b here is -8, so it becomes +8 when I plug it in. And 2a, and my a here is -1, so 2 times -1, and that's going to get me -4. Okay, so axis of symmetry is x equals -4. Going to find what my y value is now by plugging in -x² minus 8x minus 17. Alright, clear out anything that you might have in your calculator by just pressing the clear button, or you can actually write over it. That's also what you could do, and then delete anything at the end. So -x² minus 8x minus 17. That's in my y equals. Now I'm going to go to my table, second graph, and I'm going to find -4. Well, at -4, the y value is -1. And so look, the 2 points before that is going to be -5, -6, and the 2 points after that is going to be -3, -2. Hey guys, when you're looking at your graph, when you're looking at your table, if you're wondering, did I really get my vertex here at -4, -1? Well, if you look at the points before and after it, if they have the same y value, then yeah, you have your vertex because it's symmetrical now. So when x is -3 or -5, y is -2. When x is -6 or -2, y is -5. Okay. Oop. Go find my graph, or sorry, go find my vertex point, -4, -1. -4 is right here, down 1. There's my first point. All right, then I'm going to be graphing to the left and right. And so this time it's going to be at -5. It's going to be -2. Keeps doing that. At -5, it's -2. At -3, it's -2. When the x is -6, y is -5. So I'm going to have to count down here. 1, 2, 3, 4, 5. Sorry, that was my count impression. Whatever. Okay, and so my parabola is going to open down, right? And so my domain still -infinity to +infinity. But my range now, do I have a max or minimum? Well, hopefully you're saying, well, it's a max, right? That vertex is going to be the highest point it reads. So everything is y less than or equal to -1. Okay? Let's do another one. So 4, -2x squared plus 4x plus 1. All right, so my x here, my axis of symmetry is, again, x equals -b over 2a. All right, you should all know that. All right, and my b here is 4, +4, and so it becomes -4 when I plug in, over 2a. So 2 times -2, that's going to get me +1. So x equals 1. So my vertex is when x is 1. And let's go use our calculator. So -2x squared plus 4x plus 1. Go to the second table. And I'm going to look, where is x equals 1? Okay, and it's right there. It's 3. Y is 3. Okay, so that's my vertex, 1 and 3. All right. So then I'm going to be graphing 2 points before and 2 points after that, which means this is going to be 0, -1 up here, and this is going to be 2, 3. Okay, so let's put those points. When x is 0 or 2, the line is at 1. All right, and when x is -1 or 3, the point is -5. All right, or the y value is. So go find 1, 3, which is over 1 up 3. So there's my 1, 3. Put that first point. Then I'm graphing for when x is 0 and 1, or 2, sorry. So right here, and -1, it's at -5. So go over 1 and down 5. 1, 2, 3, 4, 5, right there. Okay, then it's also 3, -5. So 1, 2, 3, 4, 5. All right. So you can kind of see this parabola. It opens down, but it's also a little bit skinnier. That's a terrible line. Let me do that again. Okay. Sometimes it's just easier to do it in 2 parts. All right, missed that point, but that's okay. All right, there you go. All right, so my domain here is from -infinity to +infinity. Again, that really never changes, okay? This time, do I have a min or max? Well, hopefully you can see this opens down, so my vertex is my maximum. So everything is going to be equal to or less than 3, because that's my highest point on this graph. All right. One more, and then I think we can call it done. All right, x squared minus 6x plus 11. Let's find our vertex first. X equals negative b over 2a. All right, my b here is negative 6, so it becomes positive 6 when I plug in. And then 2 times just 1 will be 3. All right, so axis symmetry is 3. I'm going to put that number in the middle of my table, x equals 3. And take my calculator, x squared minus 6x plus 11. All right, so I'm going to find 3 when I'm going to go to my table, find 3 on my x value, and so you can see that y is 2. So my vertex is 3, 2. That's my first point, so go right 3, up 2, there's that. All right, and then the numbers before is, of course, 2, 1, and the numbers after is 4, 5. Make sense? Good. Okay, and so now I just kind of figure out what is y when x is 2 or 4. Well, it's 3. What is y when x is 1 or 5? It's 6. Okay, you can use those points to graph. So at 2, at y is 3. Same thing for when x is 4. When x is 1, it's 6. So up 6 and right there. Okay, just make a nice line connecting all those points. And there's our parabola. It's opening up. Does it have a min or max? Minimum, right? There's a low point to this graph. So my domain, negative infinity to x to positive infinity. All right, and my range is going to be a maximum, a minimum. So that means that y is always going to be greater than or equal to 2. That's my lowest point. All right. Okay, guys, you can finish number 6 on your own, and that's what we did on Wednesday, March 6th. All right. Let me know if you have any questions or stop by at the tutorials. Okay. All right. See you guys later.